Okay, with this data set, we're going to look at the differences between income and the number of hotel rooms occupied. The income refers to a restaurant that's probably located within the hotel or right outside in the parking lot. And that the goal is to know if there are more hotel rooms occupied, will the hotel or will that restaurant make more income, make more money? So we can take a peek at it with a filter. And in this case, maybe we want to look at, let's look at what it looks like if we have like some of these higher numbers. So the hotel's making somewhere close to $1,500. If we average that, we're looking at, let's see, where's our average? $1,497 for the higher numbers. If I come back in here and I look at some of the lower numbers, then our average is about $1,415. So I don't know, it's hard to do a gut check and say, is the restaurant making more money based on the number of rooms occupied at the hotel? So what we'll do is take a look at the slope and the intercept, and I'll show you this in just a minute because this is actually going to come out on your regression table, but I wanted you to see how to do that manually as well. So the first thought here is, well, when we're looking to see if two variables are related, that's a correlation. So let's run a correlation test. And to do that, we'll go up here to data, go to data analysis, come over here to correlation, and I'm looking at both of these columns. Now I went ahead and labeled them. At the top, you'll see I labeled which one was the dependent variable, which one was the independent variable. I'll talk about that in a minute. But for the purpose of this, we do have labels here, income and occupied, and I'll hit OK. All right, so with this, the goal is if we looked at income and income, clearly they're related. They're the exact same thing, so they have a number 1. If we look at occupied and occupied, clearly they're related because it's the exact same thing. So that gives a number 1. But if we look at income of the restaurant and the number of rooms occupied, the correlation is 0.4257 so-and-so. So we can see then that there is a relationship. It's not identical because they're not the exact same thing. So it's not 1. If this was a 0, there would be no relationship. Now, coming down here, I can show you, if we put this in our chart, there is a low relationship if it's 0.00 to 0.30. This one's 0.43 though, so we're here in the moderate relationship. There's a relationship. It's not real big, but it's not super low. It's kind of in the middle. So at 0.43, which if we took this and we rounded it, that's what we get, 0.43. Okay, so there is a relationship. That's good news. Now, the next part that I want to see is, well, can the number of rooms occupied predict? That's really what your regression table is. It's predicting it, and it's looking at the variability between the two. So to figure that out, let's go back to our hotel data. And real quickly, I told you I would explain why I labeled these the way I did. Well, your y-axis is the dependent variable. That's what you're trying to predict. It's what your outcome, your desired outcome is. So in this case, we want more money at the restaurant. So we want to know if we have more rooms occupied, can we get more money? And that's how that would be worded. In fact, I would be okay with moving these around because your independent variable usually comes first and saying, if we have more rooms occupied, will we get the desired outcome of more income at the restaurant? All right, so now let's take a look at regression tests. Go back to data in your toolbar, your data analysis, and let's look at regression. Okay, let me clear this out. Now our Y range, again, that's why I labeled these so that I can keep it straight in my head, but Y is your outcome, your desired outcome. So we want to include everything here that's in Y. I'm telling it that I have the label, so that's why I can include the title. My X is our independent variable. So we're going to include this information, including that label of occupied. So we have the labels. I'd like to know about confidence, the confidence interval, and I'm not too concerned with this right now. So we'll hit OK. So you'll get a chart that looks like this. Now, if you remember, I told you that on our main page, I wanted to look at slope and y-intercept. So if you calculate the slope, you can do that by doing equals slope, parentheses, and then come up here to everything, all the numbers that's in the y. And, oh, that didn't work. Let's go back. Okay, oh, that's right, I didn't put in the x. So we're gonna do everything that's in the y. We'll put slope, all of these, comma, and now we'll put in the x, all of these, in parentheses, and there you have 1.490574. If we go back to our regression table, look at this, 1.490574. So this number that came up on your regression table is actually, if we go back here, it's your slope number. If we wanted to look at the y-intercept, you just type in intercept, so equals intercept. Same thing, we're looking at all of our y data, comma, all of our x data, into parentheses, and you have 1381.662. So if I go back over here, look at that, 1381.66. If that was rounded, it would be 2. I believe that's important just so that you can understand how this is being calculated. Let's put these back together. There you go. So you can see how that's being calculated. All right. Now, let's go back to the regression table explained. First, I'll show you. This is the regression table that was just produced with our regression analysis. I've taken this to save time, and I've shown you here all of this information. What's important in this table, I've highlighted. So the R-square, the adjusted R-square, the observations, the intercept and occupied, which I just showed you, this, and then we have the p-value. Now the R-square, this is telling us that this model is accounting for about 18% of the variability. In other words, the number of rooms rented at a hotel accounts for about 18% of the income or the variability in the income at the restaurant. So it's not much, but there is a little bit. Then we have the adjusted R-square, which in this model, I'm not concerned with. Oftentimes the adjusted R-square is the one that most people will use, but you don't need to use it if you only have one independent variable, and that's all we have. So in this case, we'll just use the 18%. All right. Now you see statistics that say n equals 25. Well, that just means that you have the number of observations is 25. And then down here, I put a lot of red text to give you information, but essentially what it's doing is all of this information is adding up and calculating into the significance, the F test. So the K minus, or the K equals 1, that's your regression, and that means we have one independent variable. Now, if we did n minus k minus 1 equals 23, well, if you remember, n is 25, so 25 minus 1 minus another 1, that equals 23. And then your total here, again, n is 25. If we subtract the 1, then we end up with 24. So that's how this is being calculated. Now we also have the SSR, SSC, and SS2. All of this is basically moving forward with our F test, and then this is our significance. If we have a p-value, this is essentially a p-value smaller than 0.05, then we agree that this is all significant. In this case it is, and you'll notice that it matches the p-value down here. So again, it is significant in that if it's less than 0.05, the rooms occupied does have an effect on the food sales at the restaurant. And that's really about all that we need to know with this. So when the question is, does the hotel room rentals have any relationship with restaurant sales? Yes, it does. It's accounting for about 18% of the variability. Now your question is, discuss possible business implications of this result and what advertising strategies might you suggest based on the data?